Alright, hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. This is multiplying polynomials. So there's going to be a few different kinds of multiplying to do. As you can see for the first four, we're multiplying, maybe you've seen something like this before and your teachers called it distributing. Like, they draw arrows from the 6v, let's say, for number 1, into the 2v and the 3. So maybe you've seen it like that before. That's a pretty popular way to do it. This is what's called distributing, and it's basically when you take one thing and you multiply it into a group of things. So this is like the first stage of what's called foiling, or group multiplying, or the total title here is multiplying polynomials. So this is like the first stage of that, and it's distributing. It's the distributive property, as they call it. So what we're going to do is we multiply 6v by 2v. So when we say 6v, that means 6 times v, or 6 v's. So if I were to add 6 v's and 2 v's, I'd have 8 v's, but I'm not adding them, I'm multiplying them. I'm going to have twice as many. So 6 times 2, I can do that. I can't really do 6 times v. That's why we call it 6v and not something else, because we don't know what v is. But I can do 6 times 2. I can skip over the v in between the 6 and the 2, because when you multiply things, you can multiply them in whatever order you want. So it makes more sense to try to multiply 6 and 2, because 6v doesn't turn into anything. It's just 6v. But 6 times 2 is 12. And in the same way, I can actually multiply the v's. So we don't know what v is, so it doesn't turn into a number or anything. But I can multiply v and v. There's two of them. There's a v right after the 6 and a v right after the 2. If I multiply them together, anything times itself is squared. Like 3 times 3 is 9, but 3 times 3 is also 3 squared, which is 9. Right? So if I do v times v, it means like a number times itself, which is that number squared. So even though I don't know what v is, I can still write it as v squared. Okay, so we're done with that part, but there's a second arrow. We have to multiply 6v by everything in the other parentheses, and you'll see that's kind of like a common theme here. So again, we can't do v times 3, but we can do 6 times 3. 6 times 3 is 18. And then I just kind of tack on that v on the end there, because I'm not multiplying 2 v's anymore. It's just 6v times 3. And I get 18v, right? So I went a little bit slow on that one if you're looking at this and you're like, wow, that was very, that was slowly explained there. I feel like I can handle more than that. What I do is I explain really slowly at first, and then we go a little bit faster as we move along. And I'll maybe slow down just a little bit if we get to something new, like for number 5, how we're kind of foiling there. But that's kind of the trend. So if you feel like I'm explaining it a little bit too slowly for you, then you'll want to move ahead a little bit where I start to explain things a little bit quicker and kind of show you what it looks like once you get the hang of it, how you should be solving it once you get the hang of it. All right, so anyways, moving on to number 2. This is 7 times negative 5. You're not subtracting because the 7 is right next to the parentheses. When you have a number right next to a parentheses, you're going to multiply it. And of course, that's the name of the worksheet too, right? So we know we're supposed to be multiplying. But it's not 7 minus 5, it's 7 times negative 5. So positive times a negative is a negative. 7 times 5 is 35. And then, of course, there's that v there. Right? There's only that one v, and that's it. So then I have 7 times negative 8, or you can think about it as minus 7 times 8, whichever one makes more sense to you, because there's a minus in between them, but a minus sign and a negative sign are actually basically the same thing. So it just depends on which one makes more sense to you. You could think about it as 7 times negative 8, or you can think about it as minus 7 times 8. 7 times 8 is 56. then we're done with number 2. All right, now we go on to number 3, and I'm going to go just a little bit faster here because we're going to be wrapping up distributing. Sorry, my arrows are not that good. I'm not that good at drawing things. We're going to do 2 times negative 2, so that's negative 4. And then there's an x times x again, just like for number 1. So x times x is x squared. Then I do 2x and a minus 3, so minus 2 times 3 is 6. And then I have an x. And that's it for that one. And then same thing for number 4. So before we move on to a little bit more complicated stuff, all I'm doing here is doing negative 4 times v, negative 4 times 1. So that's the answer. Okay. Now we get to this next section here, and I'm kind of scrolling ahead because I want to see how many of these there are. Quite a few. Yeah, so if you look ahead a little bit, not until number 19 are we going to have anything different. So again, I'll spend a little bit more time. Well, I mean, number 13 is a little bit different, but I'll show you why. That's not really that different when we get to that one. But if you look ahead here, these guys down here, and again, you can scrub ahead if you're only stuck on 19 through 23, just scrub ahead in the video. I'll show you a really cool way to think of those in the future. But for right now, we've got 2 things in parentheses and 2 things in parentheses for a while here. So what we're going to do, I'm going to go ahead and change colors for this one. We'll change to like a nice green here. When you're doing 2 and 2, when you're doing a 2 by 2, basically you want to do FOIL. And you've maybe heard of this before. FOIL. F stands for firsts. They're all plural because there's 2 of them. Firsts, outers, inners, and lasts. Firsts, outers, inners, and lasts. And actually, what I might do is I might go ahead and color code this stuff as well here. So I'm going to switch back to blue for a second here. So F is going to be blue. And then we're going to do, maybe not a solid yellow because it's a little hard to see, maybe like a nice gold for O. And then like a deep red here for I. And those are the 3 primary colors, so we'll do black for L. Okay, so blue, kind of a gold, a red, and a black for each of the letters. And I'll show you how that's going to be helpful here in a second. So let's go back to blue. So firsts, meaning the first things in each of the parentheses. So that's going to be that and that. All right, so I'm going to do 2n times 6n. 2 times 6 is 12. N times n is n squared. All right, so we just did first times the first. So now I switch colors again. And I'm going to do outer times outer. Well, the outermost things are going to be this guy again. Right, so over here. And why is that making a weird... Oh, because I'm using a highlighter. I was like, why is that? There we go. I must have clicked on the highlighter instead of the draw tool. So, oh, going back, hold on. Got distracted by the highlighter tool. We want the outers, which is going to be out here. Let me fix my mistake real quick. Okay, there we go. So the outers are the 2n and the 1. 2n times 1 is 2n. All right, back on track here. So first times the first, 2n times 6n, that's 12n squared. There's 2 n's being multiplied, so I get n squared. 6 times 2 is 12. Then just 2n times 1 for the outermost things. Then the innermost things. So that's going to be this 2, and then the 6n again. So 2 times 6n is 12n. And then for the lasts, I'm running out of space a little bit here, but it would be the 2 again there, and the 1 again there. So everything is selected twice, right? So the very first 2n was an F and an O. The 2 after that was an I and an L. The 6n after that was an F and an I, and the 1 after that was an O and an L. All of them get 2 different letters, and we combine them all, and 2 times 1 is 2. So I put that right there. All right. So I'm going to switch back to green now, since that was kind of the color I wanted to use on these problems here. And I won't color code like that for the rest of them, just for number 5, so you can see what happens. But there's always, usually always, like 95% of the time, you'll combine the middle terms, because they're going to be like terms. Right, so 12n squared, nothing happens there. 2n plus 12n is 14n. And I guess I could have used orange for that one. Yellow and red make orange, but it's all good. I don't need to go too crazy with the color combining thing. So that's actually the final answer then. All right, that took a little bit more time, right? It kind of ramped up a little bit there. 12n squared plus 14n plus 2 is our final answer for number 5. So before I go on to number 6, there's kind of a trick. So we can do FOIL, right? FOIL is fine. When we get to the later questions, FOIL's not going to be enough because we're not going to have 2 by 2. We're going to have 2 by 3, or even more than that sometimes. When that happens, you want to think of it a little bit more like distributing. If we ignore the 2, right, not the 2 next to the n, that's 2n. I'm going to call that 2n. But the other 2, right, this one. If we were to ignore that 2, like just pretend it wasn't there, it would just be a distributing problem. I would just do 2n times 6n, and then 2n times 1. Well, that's exactly what I did for the first 2 steps, actually. Right? First times the first, 2n times 6n, and then 2n times 1. The outer, the first and the first, the outer and the outer. So when I ignore that 2, I'm basically just distributing the 2n. Then I do the opposite. So then instead of ignoring the 2, I ignore this 2n, because I'm done with it. I'm done distributing the 2n. So I distributed the 2n into the 6n and the 1, and then I kind of ignore that one now. And now I'm distributing the 2. 2 times 6n, inner times inner, 2 times 1, last times last. But that's all I'm doing, is I'm basically taking each thing in the leftmost parentheses, focusing on one thing at a time, and distributing into the second parentheses the thing that I'm focusing on in the first parentheses. Okay? So that's kind of the more intuitive, more holistic way to think about distributing, because that's really what it's going to come down to later on. But I'll show you another little trick for later on too that might help. So let's get into this one. First times the first. So I'm going to go ahead and label these again. I'm not going to use the color coding because it takes a little bit of time to do that, but I am going to label this next one number 6, but then I'm not going to label them after that. 4n times 2n, 4 times 2 is 8, n squared. That's an n. Totally an n. And then 4n outer times the outer. 4n times 6. 6 times 4 is 24n. Inner times the inner. 1 times 2n is 2n. I need to make a little barrier here. And then last times the last. Last times the last. 1 times 6 is 6. And then we combine the middle terms. And like I said, you're almost always going to combine the middle terms. There are some times that you wouldn't, and we might run into one of those later on. But for right now, we're always going to combine those middle terms. All right, I think I'm just going to keep with the same shade of green, at least for this page, and then I'll just change colors when we get to the next page. So first times the first, 6x squared. Outer times the outer, minus 2x. Inner times the inner, minus 18x. Last times the last, positive 6. All right, I went a little bit faster on that one. Minus 20x plus 6. There's the final answer. All right, so I'm starting to go a little bit at the pace that I would normally go if I were solving them out myself, but I haven't quite gotten to where the pace is that I would solve these out at yet. I'm kind of slowly building into that. 8 times 6 is 48. P squared. Outer times the outer, 16p. Inner times the inner, minus 12p. Last times the last, 4, minus 4. 48, p squared, plus 4p, minus 4. All right, moving on. So on this one, I'm not going to say it out you know, the first and the outers and inners and lasts and stuff, or we're just going to kind of say what I'm multiplying before I multiply it. So 6p times 5p, 6p times negative 8, 8 times 5p, and 8 times negative 8. All right, so 30p squared minus 8p minus 64. All right, next. So here I'm just going to kind of write out what I'm actually getting for an answer here. So 24m squared plus 21m minus 8m, that's an m, minus 7. So 24m squared plus, and I blinked out that for a second. Sometimes subtracting with carrying is hard, even even after all this time of doing math. 13. Sometimes you just get stuck on those carrying problems with subtraction, so don't feel bad if you're like, wait, I forgot what that was. You're all good. Okay, we still got a few more here, so I'm not gonna go to the level that I would go if I were to solve it out myself just yet, but we'll go ahead and kind of continue to build momentum here. Minus 8a plus 5. 16a squared minus 18a plus 5. All right, then here we've got 25n squared minus 25n plus 30n minus 30. And trying to squeeze in a 0, that's a 0. 25n squared plus 5n minus 30. All right, so number 13, remember I was saying, like, I kind of skimmed over 13 at first, because I was like, oh yeah, all of these are the same. So number 13 doesn't look like the same kind of problem as what we've just been doing, but it actually is. It actually is. And you know what? Let me go ahead and switch to a color I haven't really used yet. Let's do like a nice purple kind of color. So 13 is a little bit different from the others, but notice it's surrounded by a sea of 2 things times 2 things. Or the more fancy way to say it would be binomial multiplication. That's like a fancy way to say it, because binomial means 2 things, 2 terms. So this is actually the same thing. You would be careful to not try to distribute the 2. You can distribute the number 2, but only when it's being multiplied by 4p minus 1. So we do want to distribute 2's, 100%, definitely, but we would have the 2 would normally be to the left of the parentheses and the 4. It would normally be there if we distributed the 2, not up in the top right. You don't distribute the 2 in the top right. If you've got like a trinomial or binomial or anything like that, you're not going to distribute it into each of those terms like you do a regular 2 out front. Okay, and we can get more into when you might distribute a power of 2 some other time. But here, just know that when you see this, you probably want to rewrite it before we multiply this out. Because you can multiply it out, but you want to rewrite it first. This is the same thing as 4p minus 1 squared. Something quantity squared means that thing times itself, right? So 4p minus 1 times itself, that's what squared means. It means the number times itself. So this is what we're actually doing. Now this, number 13, is no different than the other ones, because it's 2 things times 2 things, right? So this is now no different than the others. So now we just multiply it out. 16p squared minus 4p minus 4p plus 1. So then we get 16p squared minus 8p plus 1. And that's it for that one, right? And the rest of these are the same as before, so I'm actually going to start to go kind of at the same pace. I'll do one more here at the pace I was going before, and then we'll kind of bump it up a little bit. I'll show you what I mean by bump up the pace. It's something that you don't want to try until you feel a lot more confident with this. So if you feel pretty confident with it and you just want to get even better, that's what I'm going to show you next. So I wouldn't try it until you feel ready solving these guys out. Okay, so there's that. All right, so what I'm going to do is for the next 4, I'm going to just write out the answer and skip the middle step. So what I'm going to do is I'm actually going to do the 2 middle terms and put them together in my head. Okay, the 2 middle terms pretty much always go together. It's very rare that they don't go together. You would know that they might not go together if, let's say, we had, for instance, number 15. Let's say it was 6n squared plus 3, and then the other one was 6n minus 4. So then the powers are not the same. If the powers don't match up just right, then you might not have middle terms to put together. If the powers are the same, so like 6n and 6n, they have a power of 1 for each of those. It's not n squared or n cubed or anything like that. So we know we're going to combine the middle terms. Okay, and the same goes with the numbers. The 3 and the 4 don't have any powers. They don't have any. They're not multiplied by a letter, right, or a letter to a power or anything like that. So it's the same kind of thing, right? Like I have an n and then like a number, a 6n, right, just an n, and then a number, the 3, and then a 6n, same power. The fact that they're both 6n's doesn't really matter. The 6 doesn't matter here. It's the power of n that matters. And then the 4, right? No power. No power of a variable. Okay, so let's dive in. So this would be 36 n squared. And then we're going to do the next part. So 6 times 4 is negative 24, and then 18, right? So negative 24 and 18, that's going to be minus 6, right? Minus 6n minus 12. And there we go. All right, so then for 16, do the same thing. That's 48n squared. 8n times negative 3 is negative 24n. Negative 24n, okay, so hold that. And then 6n times 1, or 1 times 6n, that's 6n. So negative 24n, positive 6n, that's negative 18n, minus 3. All right, see how I'm doing that? I'm kind of doing it in my head. All right, so again, don't try this until you're really ready. But this is a faster way to do it. All right, so then that's going to be 30 and 25, which make 55, plus 25. And that's a 5. Sometimes my 5 looks like 3's. All right, 12x squared. 9 and minus 16. So that's a minus 7. And I almost put a plus there. I want to do fiddle erase. There we go. Minus 12 there. Okay, so now we're getting into the last segment here. So I'm going to change color again. Maybe like a brown. We haven't really done like a brownish color, kind of like a tertiary color yet. Pretty much only primary and secondary colors besides black. So before I get into this last section here, I'll share with you this way, and I kind of mentioned this earlier, of like how to think about this. 2 ways actually before we dive into this last set here. So if you already kind of know how to do this, but you just want to see if you got the right answers, you don't have to wait for me. You can scrub ahead, or you can actually just look up the name of this worksheet and it'll give you the answers to it. And we'll check our answers in a second. But before we get on to this last section here, if this video has been helpful, it's been helping you, you're probably thinking, like, oh, he's going to ask me to like and subscribe. Well, I mean, you know, if you want to, I'm not going to stop you. But actually, no. If you think this has been helpful, if you think that I've been helping you, then what I do is I try to make resources like this video, but also like just regular, you know, print textbook type resources. Like, you know, you just go to a webpage and read about how to do something in math. I'm working on doing some of that stuff too, and I'm going to have more and more resources like that on my website, myersmathematics.com. So if you're watching this video and this is an older video, like at least a year or so old, then there's probably already quite a few resources there on the website for you to look at. And one of those, probably the one that I'll spend the most time working on and making better, is the 5 math mistakes everyone makes and how to avoid them. And if it gets renamed, it'll probably be the top 5 again, but it'll be focused on how to help you get the math problem right, not how to identify what's going wrong. So that does provide a solution. Currently, at the time of this video, it's still geared towards being able to identify which of the 5 math mistakes you're probably making, and then how to avoid them, as the title suggests. Long title, probably need to work on the name, I know. But in the future, I'll have one that's geared more towards the 5 ways you can get math problems right, to make sure you get them right. So it's a little bit more of a positive spin to that. So anyways, if that sounds like something that might be helpful to you, then you can go check that out. That's one of my free resources on my website, myersmathematics.com. So go check that out and see if that's helpful. And let me know, either in the comments or in an email. I've got my email down in the description below as well for tutoring primarily, but you can just shoot me an email and let me know what you think. And I would love to know what you think. What can I do to make it better, or what's already really great about some of my resources that I have out there for you guys. Yeah, just give me feedback. I would love feedback, and that way I can make stuff even better for you. But anyways, let's go ahead and dive into the last bit here. So, for number 19, earlier I was saying, ultimately you want to distribute. So, if I ignore the 2, remember I was kind of drawing an arrow to the 2. If I ignore the 2, I would distribute the 4a into the 6a squared, the minus a, and the 2. I would distribute it into 3 things. And then ignore the 4a and distribute the 2 next. Distribute the 2 into the 6a squared, the minus a, and the plus 2. So that method of thinking works on anything, right? It's not like a special trick method like the FOIL method is. That method of thinking works on everything. Just think of taking each thing in the first parentheses and distributing it into all the things in the second parentheses. And if you do that, then you'll get the answer. That's the mentality you want to get to be able to solve any of these problems with ease. Now, if that was a little bit confusing, here's a little maybe trick or maybe an illustration that might help. So let's say you're dating somebody, and like, it's things are getting serious and it's time to meet the parents. Whew. So let's say you have mom and dad at the house, and they have mom, dad, and an older brother that is a protective older brother, maybe. And so that's what's going on here for number 19. 4a can be your dad, and 2 can be your mom. And then for the other parentheses, let's say 6a squared is their dad, minus a is their mom, and the positive 2 is the concerned older brother. So when they meet each other, they'll, do handshakes or high fives or his fist bumps or whatever. When they do that, we're going to have that represent multiplying, right? So 4a, your dad, and 6a squared, the other dad, they haven't met yet, right? So they're going to do a nice solid handshake, right? So they're going to multiply. 4 times 6 is 24, a cubed, right? And that just represents that they've said hi to each other, right? And then your dad, 4a, still hasn't met the other person's mom, your significant other's mom, which would be minus a. So 4a times minus a, right? 4a squared. Now your dad and their mom have met, shaken hands. Then your dad, 4a, is going to meet their older brother. 4a times 2, 8a. Okay, now your dad has met their dad, mom, and brother. So your dad is done, shaking hands or whatever with their family, their whole family that's present. Just mom, dad, and brother are present, I guess. So then your dad's done, but your mom hasn't met anybody yet, right? Your dad was busy introducing himself. Now your mom, too, needs to meet their parents. So your mom is going to meet their dad. 2 times 6 is 12, a squared. Your mom has met their dad. Then your mom meets their mom, minus 2a, 2 times negative a. And then your mom meets their brother, 4. All right, this is a little bit long. So we'll start to consolidate pretty quickly here because we need to, because we'll run out of space. But now everybody's met everybody. Okay, so the only way I think that people normally mess this up is they accidentally multiply 4a, your dad, by 2, your mom, right? Not the other two. The 4a and the 2 that are in the same parentheses. If you were to multiply those, that wouldn't make any sense. Your mom doesn't need to say hi to your dad. They already know each other. Or, hopefully they do. So if your parents already know each other, then they don't need to say hi. Be like, oh yeah, I'm so and so. Like, yeah, no duh. So that's kind of the mentality that you can have. If that helps and if that resonates with you, then awesome. If not, the better way ultimately is going to be to just think about it in terms of distributing the 4a into everything in the right hand side parentheses, and then distributing the 2 into everything, which is actually what I just did, just kind of with an illustration. So now I'm going to consolidate some like terms. 24a cubed. I've got 2a squared terms right here and right here. So you have to be careful with the like terms. The 2 middle terms is no longer as nice and neat anymore. So what helps sometimes is to get rid of them as you go. Negative 4 plus 12 is plus 8. Plus 8a squared. Okay, and then we have 2a terms. 8 minus 2 is 6. And then we just have that 4 left over. All right, and that was everything. Okay, a little bit more complicated, but as I go here, I won't spend as much time going over it. Like I was saying before, I'll kind of speed up as I go here, and we'll start consolidating a little faster. Okay, so then what we're going to do here is 7k times all the things in the rightmost parentheses. We're going to distribute the 7k. So 7k cubed. 7k times minus 2k, that's minus 14k squared. 7k times 7 is 49. Okay. Now we're done distributing the 7k, so I can kind of get rid of that too if I want. Then I'm going to distribute the minus 3. Right? So then I'm going to move this down a little bit. Minus 3k squared and plus 2k, sorry, plus 6k, minus 3 times minus 2, and then minus 21. All right, so the first term almost never combines with something else, especially if it's in like a certain order. But this one and this one, they'll go together. Minus 17k squared. 49 plus 6 is 55k minus 21. And I believe that's everything. All right, cool. So we will start to speed up a little bit. We've actually only the ones that you can see right now are the ones that we have left. So I'll start to consolidate a little bit more here. And we'll go ahead and wrap things up here. So the first one is just the first times the first. All right. Then remember, there's going to be 2 square terms. 2 square terms. 7r squared minus 4, so that's minus 28. So you need to kind of hold that into your working memory. Minus 28 for the r squared. And then there's going to be another r squared. So minus 28 and then a minus 12. Minus 28 and a minus 12 makes a minus 40 r squared. So this is the method that I was mentioning earlier, except it's even harder now because we have to do it twice. So this is only the method that you want to do when you feel really comfortable distributing and you want to challenge yourself a little bit, okay? Doing the middle part in your head. So I did the r squareds together, then I do the r's together. So minus 6r and minus 4, positive 24r. And then I'm going to have a minus 12r. Positive 24 and minus 12 is positive 12r. So I just combined the r terms. And then I have plus 24. All right, so I just did 24 all in one go there. Okay, but again, you just got to be really careful. So 2n cubed, right, first in the first. Then I'm going to have minus 4 for an n squared, minus 4 and a positive 12 n squared, minus 4, positive 12, positive 8 n squared. Then I'm going to have a minus 24 n squared and a minus 12, or sorry, a minus 8. Minus 24 and a minus 8. So it's minus 32 n, and then plus 16. Right, just got two more here. So now we've got 3 on 3. Okay, so I'm actually going to write this one out because we haven't done a 3 on 3 yet. We'll just switch back to black for the rest. And multiply this out one by 1 here, but then on number 24, we'll do it, all the middle stuff in the head again here. So just all in the head, just all up in the noggin. So 42 into the 4th plus 36 n cubed minus 30 n squared minus 42 n cubed minus 36 n squared plus 30 n minus 35 n squared minus 30 n and plus 25. I just barely fit that in there. So the 42, that's never going to combine with anything. As long as they're in descending order, that first one and the last one don't combine with anything. So we've got n cubed. So that's a minus 42, positive 36, that's a minus 6 n cubed. We've got 1, 2, 3 square terms. I don't know if I'm going to try. I'm going to try it, but we'll see if I get it right. It looks like they're all negative, so I'm going to add them all up. 3, 3, 3, that's 9. 5 and 6 is 11, so that's 101, like the Dalmatians. 101 n squared. Boom, boom, boom. And we have two n's, so that actually cancels. 30 minus 30, and then we have a plus 25. And there we go. Okay, so that means that we're going to have 2 n cubes, 3 n squareds, or for 24, we're going to have m's, and then so 2 of the 3's, 2 of the 1's, and 3 of the 2's. Oof, okay, let's see if we can do this. 7 m to the 4th. That part's fairly easy. Now, for the cubes, there's going to be 2 of them, so we're not to the hardest part yet. Minus 3m cubed. Okay, so minus 3. And then minus 7m times 7m squared, that's minus 49. So minus 3 minus 49 minus 52 m cubed. Okay, so then we are going to do the 3 m squared terms. So there's a minus 7, and maybe I'll write this off to the side here. Minus 7 is one of their m squareds. Then another one is a 21 m squared. And then the last one is a minus 42. A minus 42. So a 21 minus 7 is going to be 14. And then 14 and 42. Maybe it's easier to do 42 and 21 first, because then that would just be 21, because 42 is 21 doubled. So it'll be minus 21, and a minus 7 is a minus 28. There we go. Minus 28. So I kind of cheated a little bit on that one, but I'm not on my A game today. Otherwise, yeah, totally do them ahead. But now we're going to have 2 m terms. So we would have positive 49m, positive 49, and a positive 18. So positive 49, positive 18. So that's going to be 67m plus 42. Okay, so again, I'm not in my game. I don't remember if it is. Let's see if we got it. So 7m to the fourth, because we can see all the answers here. 7m to the fourth. Minus 52, minus 28, minus 52. My working memory is terrible. Minus 52, minus 28, plus 67, plus 42. Yeah, I think that's what they said. Plus 67, plus 42. Look at that, we got it. All right, cool. And then we are missing an in term for number 23, like we thought, because it canceled out. And look at that. Here's all the answers. You can check me. Let me know if I missed anything in the comments. I don't think I did. And that's it for today. So again, if you found this video helpful, then maybe some of my other resources might resonate with you as well. On my website, myersmathematics.com, go check those out and see if they help you at all. And have a great day. I'll see you on the next video.